Hello class, this is Travis Van Leeuwen, one of the graduate teaching assistants for EMEC 361, the Mechanical Measurements and Instrumentation class. I'm going to walk you through what would have been Lab 10, the strain gauge pressure transducer lab. So we're going to go through a couple of things. This lab is pretty involved. We're going to have to attach a strain gauge to one of these pressure dials here, these board-on tubes. Yeah. So the back side has these copper bands. We're going to fix the strain gauge to the back side of one of these, preferably somewhere in the middle here so we get the most deflection we can. And then we're going to solder the connections of that strain gauge to some leads that we can wire to our data acquisition box, and then incorporate that into a Wheatstone bridge circuit, balance it out using the manufacturer published value for the strain gauge, which is 350 ohms. We'll calculate our voltage source based off of the operating condition of 25 milliamps for current. And then we're going to record the voltage across the strain gauge. And in LabVIEW, we're going to design a script that will incorporate a manually entered pressure and the recorded voltage, and it'll send both of those as an array to our spreadsheet. We're also going to be taking mean values of the voltage readings, so we're running it at 1000 Hertz. I'll just run the script for a few seconds at a time, so we're getting the mean value of a few thousand samples for each point. And when we get to the LabVIEW part, we'll only be transferring the mean value, so 1 point per set, but it's a mean of a couple thousand points. So let's look at our Wheatstone bridge first. So to balance it out, we're going to assign the resistors all the same value of 350 ohms based off of the manufacturer's value of 350 ohms for our strain gauge. And so we're going to need to calculate the voltage source EI at the bottom there. Doing that, we can just take, for example, the top two resistors, right, and write a simplified circuit. So if we have two 350 ohm resistors in series and we want 25 milliamps tops to run through them, that calculated value is 17.5 volts. So we'll go ahead and use 15 volts for our operating voltage, our EI, for our circuit. So now if we come back over to here, let's zoom out. Okay. So to attach the strain gauge correctly to the board-on tube, we're going to need to sand this a little bit, this copper here on the back. Just grab some sandpaper. We just want to get it to where it's pretty uniformly shiny. You can feel it a little bit to see if there's any roughness to it or any big bumps, any leftover super glue or strain gauge bits from last semester's classes. That looks pretty good. So next, you want to take a cotton swab that's had alcohol applied to it already, and you'll just clean the back, get any residues off there. And after you clean it with alcohol, you'll want to refrain from touching it, getting any oil on there. Switch to the dry side. Just get the rest off. Okay, cool. So now, in order to attach the strain gauge, And see, I've got, this one's busted, but I'm just going to use it for an example. Alright, so there it is, little tiny guy. Get in focus there. Okay. So, oh no. It's alright. Not going to use it for real anyways. So, to get this onto the board on tube, good little trick is just to use some adhesive tape, right? And you'll just want to try and get it centered and more or less straight with the tape so that we can come to the board on tube and use the tape to align our strain gauge. Kind of get it as close as we can to the center of the copper, and we want to line up the long edge of the strain gauge with the edges of the copper. So that's pretty good. It's not bad. And we've got it kind of centered there on the overall board on tube. We could even maybe just move it back a little bit there. That'd probably give you better results if we placed it there, right? So that looks okay. So now the next part is to bond this to the board on tube with some super glue, right? So take our super glue cap off, and what you'll do is just peel the tape back until the strain gauge is slightly lifted. Then you'll want to apply just a real small amount. This tube's almost used. Just a little tiny bead of super glue. See? Just a tiny little bead where the strain gauge is going to go. And then I'll just press that out. So you got a good seal on it. Okay, and let it dry for a few minutes, right? Cool. Well, okay, let's just fast forward. After it's done drying, right, you'll peel that tape off all the way, and you'll want to get to the little leads here. Let's see. Let's zoom out. Maybe it'll be a little bit easier to see now. The two leads of the strain gauge, right? We're going to want to solder them. Fun. So, solder. I'm not going to demonstrate this live, but just show you, right? Soldering iron, solder, cool. Heat the joint up between the raw lead and the lead of the strain gauge. Apply a little bit of solder, and then tape your connection. So I spent too much time already trying to get that one set up, so I'm gonna skip showing you guys the soldering part. But once you do attach your two leads via solder, you want to cover them with just some tape to ensure their connection stays strong. My two leads are attached via banana clips, right? And that's going to incorporate it into the rest of my circuit. Okay, so I've got my 3 decade boxes set to 350 ohms. I've got my pressure transducer connected, my strain gauge attached to the board on tube, and all wired up. Got my data acquisition box, right, which is measuring our EO or E out, right? So there's our positive end, our negative end. I've got my voltage supply hooked up, set to 15 volts, and I've got my strain gauges, or my decade boxes, connected and to my strain gauge as well. So now let's take a look at the LabVIEW. So, let's go ahead. Okay. So we've got our data acquisition assistant, of course. And I've got a rate control set up here for 1000 Hertz. My data is flowing out into a mean function, right? So I can read the mean voltage because it's not going to be at 0 volts initially, so we're going to have to offset the data by subtracting the mean out. So we'll record the mean for 0 psi, and then we'll take that and manually enter it here, right? So that we're subtracting the mean out. We can feed that data into a waveform chart if we want to see the adjusted data. But then we're going to take a second mean, and we're going to average the adjusted data out before we continue out of the while loop, right? So you can see we're doing continuous sampling, so we have a while loop installed. But after we hit stop, it'll take that second mean value and it's going to put it into this merge signal function. Okay, and that merge signal function is going to take our mean value, our adjusted mean value, and it's going to combine it with this numeric control that I've called PSI, because we're going to actually enter in the PSI by hand. So now that merge signal data is going into a write to delimited spreadsheet function. I mean, we've done this plenty of times, but we're going to need a format control, a file path control, an append to file control, a transpose control, and a delimiter control. So let's take a look at our front panel. So our front panel, right in the top left here, we have all of our controls. We have our file path, we have our rate, and we have our mean raw data. This is our raw data itself. This is the mean value of the raw data. Here's the offset y, which we will put that mean value data into. Then here's the PSI control. So we'll change that as we go along. And then over here, this is the adjusted data and the mean adjusted data. So you can see what it is about before it goes through the pipeline. So right now, everything is shut off, but I'll go ahead and run this code to show the mean adjustment, at least. So let me go ahead, clear this graph, clear this graph. So now if we run it without the adjusted value, or without the offset, right, these are both negative 0.04, and they look the same. So we can go ahead and hit stop. And we'll copy that data into here. And we'll hit run again. And now the data on the right there is reading 0. And it's hovering a little bit closer to 0 than that one is. Alright, so there's our adjusted data, adjusted for offset. So what we would do then for the lab itself, if this were to be running, we have an air compressor hooked up to this piping, or these tubing. Tubing is hooked up to these board-on tubes. Board-on tubes have the strain gauges attached to them. So I'll go ahead and at least run one of them. So I'm going to turn the pressure up to 15 psi. You can see the dial on the board-on tube moving. That's not exactly accurate, so you can ignore that. But let's go to our data here. Alright, so it was reading 0 before. Let's go ahead and put in 15, and we're going to hit run. and it's a little step up. The mean value still says 0, but that's only reporting to 2 decimal places on that screen right there. Let's go ahead and open up the Excel sheet, see what that looks like. So you can see our values here, right? I'm writing in 2 values at the same time. The PSI is on the right and the actual voltages are on the left. And so this first one was without adjusting for that offset value. And the second one is with adjusting that offset value. Alright, so we can see a change here between 0 and 15 PSI. Let's go ahead and do one more. We'll do 30 and see what that looks like. Okay, so I adjusted the pressure in the system to 30 psi, so I'll change that to 30, and we hit run. Okay, we can hit stop. And let's check that Excel sheet. Okay, and there we go. Alright. So another change from 15 to 30 psi. So we'd repeat that in increments of 15 from 0 to 90. And eventually you get a table set a lot like this one. And so you can see we have a change in voltage as our pressure changes. And that about wraps it up for this one, guys. The data will be posted on D2L in addition to this video, and I will also take pictures of the setup and the air compressor and everything else. I hope you all are doing well, staying safe, staying healthy, and hopefully we'll see you back next semester. Alright. Thank you very much. Have a good one.